How's it going, everybody? Today we are multiplying and dividing radicals. So, hop over to that page. Should be page 4 for you. Multiplying and dividing. So we need to go back to those rules that we used in the last lesson, the multiplication property and the division property for radicals. So just remember here that we've got the multiplication property where we can take the product of things inside of the radical and split them up, so make it the product of two radicals. Or we've got the division property where we can have a quotient underneath the radical and we could actually split that up into two separate radicals and do the quotient of those. And just remember too, you can also go back the other way if needed. So when we are multiplying, things that you're going to follow. You want to first find the product of the terms that are on the outside of the radicals. And then find the product of the terms that are underneath the radicals. And then finally simplify if you can. So let's look at some examples here. We've got radical 2 times radical 6. So we don't have any numbers outside of the radical, so we don't have to worry about step 1 there. But we can find the product of the terms underneath. So let's see what that looks like here. Well, that would be radical. We could put the 2 times 6 underneath, which would be radical 12. Okay. Then we want to ask ourselves, does that simplify any? Or do we have any factors that can come out of there that might be perfect squares? Well, we do. 4 and 3 are factors of 12, and we know that 4 is a perfect square. It breaks into 2 and 2, giving us that pair that we need that we can pull outside the radical. So our final answer, we're going to pull out that 2, and then the 3 is going to stay underneath. All right, next one. Now we have where we've got 3 and 4 outside of the radical, 5 and 10 underneath the radicals. So we're going to multiply that stuff together. So we're going to have the 3 times the 4, the product of the terms on the outside. And then underneath, we're going to do 5 times 10. So what do we get? 3 times 4 is 12. And then the square root of 50. And then again, we want to simplify if we can. So 50, can you think of any factors of 50 that might be a perfect square? How about 25 and 2? And we know that 25 will split into 5 and 5. It's a perfect square. So now what happens is we have our 12, but we're pulling out a 5 of our radical. And we've got a radical 2 underneath. So that 12 and the 5 are going to get multiplied. So what we're going to end up with is 60 radical 2 after we simplify. Got it. Next example here. Now, this one looks a little bit tricky. There are no terms outside of the radical, so let's just multiply the insides together and see what we get. So we have the square root, and we want to do 2 times 128, and we want to do y times y to the 5th. And then what do we get? So 2 times 128, 256. And then remember your exponent rules, y is y to the 1st, and then when we multiply we should add those exponents together, so we get y to the 6th. And then you try to take the square root, and if you check, 256 should be a perfect square, and that would be 16. And then if you take the square root of y to the 6th, that's going to give us y to the 3rd. So that one, the radicals totally simplify. Number 4 here, we've got terms outside the radicals and underneath. And they're cube roots this time, so you have to be careful. Watch out for that. So we still want to do the negative 6 times the 2. So what's on the outside there? Negative 6 times 2 is going to give us a negative 12. And then what do we have underneath the cube root? Well, we've got 9 and 3, so we want to multiply those. That's going to give us 27. And then we have a, remember again, that's a to the 1st. And then a to the 4th, we multiply those together, that should give us a to the 5th. All right, now we want to simplify. 27 is a perfect cube, so we can pull out that guy. The cube root of 27 is 3. And then what can we pull out? A to the 5th. Let's think about our shortcut. So 5 divided by 3 is going to give us 1 with a remainder of 2. So we can pull out one group of those a's, and then the cube root, we're still going to have a squared left over underneath. And then we want to simplify. So negative 12 times 3 is going to be negative 36a, and then the cube root of a squared. And that will be our answer. All right, next page. We divide radicals this time. We're going to follow these steps. So find the quotient of the terms outside, or simplify or reduce those. Find the quotient of the terms inside if that helps us. Try to simplify the radicals. And then once you get your final fraction, simplify that if possible. So let's hop on down to our examples. Now this is a little bit trickier than the multiplying because you have to kind of figure out what's going to help us. So for example, if we do 2 and then square root of 5 divided by the square root of 8, well, 5 and 8 doesn't reduce if we would combine those on the inside and do like 5 divided by 8 underneath the radical. So what we might want to try to do is to simplify the radicals then. What do you know about radical 8? What will that break up into? Radical 5 doesn't have any other important factors, but 8 does. 8 is 4 and 2, giving us 2 and 2. So we can take a 2 out of that radical, and we have 1, 2 left over, so ends up leaving us with this. Now, our 2's that are out in front will reduce, and that's just going to leave us with radical 5 over radical 2. And you can leave it like that. If you wanted to put it underneath, you could leave it like that. That's also correct. So either one should be fine. I would probably use this one. All right, number 2. So 9 and 3, well, that reduces. 9 divided by 3 is 3. And then this time, 48 divided by 24, that does simplify. So let's go ahead and do that. What is 48 divided by 24? Well, that's 2. So 3 square root of 2. And that is fully simplified. Can't go any more beyond square root of 2. Next guy here. 5x radical 6 divided by radical 6x to the third. So again, let's kind of think about this. Notice how the 6x and the 6x to the third have quite a bit in common there. So let's see, we could try to just combine those underneath the radical and divide them, or you could try to simplify if you want. Let's just go ahead, 5x and then the square root of 6x over 6x to the third. So how does that reduce? The 6's cancel, and this would be x to the first over x to the third. Remember your exponent rules. So 5x, and then we could have x to the negative 2, but then let's remember and put that underneath the fraction bar. Put the x squared in the denominator because we don't want to have a negative exponent. So then we want to try to simplify this. So now if we take this guy and we split that back up and do the square root of 1 over the square root of x squared, what would that leave us with if we take this guy and change it to this? So we would have our 5x still out in front. The square root of 1 is just 1. And then the square root of x squared would be x. So we'd have this guy, and then 1 over x and x are going to reduce. So this whole thing is just going to be 5. All right, last example here, number 4. We have x and then the 4th root of 32 divided by the 4th root of 2x to the 8th. So we can try to simplify, or we can combine things under the radical, whatever works better for you. I'm going to go ahead and let's do the simplifying this time. Last time we put it underneath the radical. Let's try simplifying first and then see what happens. So 32, the fourth root of 32. Well, let's think about 32 for a second. Now it's a fourth root, so we're looking for groups of 4 or a perfect fourth. So 32 has factors of 16 and 2. And 16 is actually the same as 2 to the 4th power. So that's a perfect fourth. So we can take that out. So it would be x and then times 2. And then the fourth root, what was left over? Another 2 divided by. Now our fourth root of 2x to the 8th. So we're still going to have the fourth root of 2. And then what about our x's? If we do, let's come down here, 8 divided by that root number, which is 4, well, that comes out evenly. That's going to be 2. So we're going to have an x squared come out from that fourth root of x to the 8th. And then we want to simplify. So our fourth roots of 2 are actually going to reduce. So those are gone. And then this would be x to the first. That's going to cancel out one of those x's. So all we have left then, on the top we've got a 2. On the bottom we've got an x left over. So 2 over x. Got it. All right, that's it for today. I hope you enjoy the little comic underneath. Get started on your assignment. Make sure you're asking for help if you need it. Good luck.